Hi everyone, welcome back. And very, very cool. Amanda, that is awesome. That makes me super happy because that's what I'm trying to do here. I'm trying to make this dynamic, fun, and I know they're lecture videos, so I know they're long and if anybody's watching them again at a later point, but I mean it covers all the topics, so why not? I will make smaller videos. Johanna, welcome. Awesome. Okay, so what we're going to do today is we are going to continue through our Unit 2 guided notes. So last class we started to really dig into how do you solve linear equations and what techniques and strategies can you use to make it easier on you. My advice to all of you was please, if you can, if you'd like, maybe this could become part of your learning styles. Distribute to drop parentheses first. That's going to make life really easy. Distribute to drop parentheses first. Then, if you have fractions in your equation, multiply every single term in the equation by the common denominator, by an LCD or just a CD, because that'll work either way. Let's go to our notes. Fractions again. Yay! All right, so for number 7, we have 5/9 parentheses 18x minus 9 plus 10x equals 12 plus 13. Now, because I'm feeling very, very generous, I would simply like to go through this problem with you. I'm sure some of you are already working through this problem. I know it. Like I'm positive some of you are already doing this right now as we speak, which is fantastic. So I'm going to walk us through just to make sure that we're all on the same page. So as my strategy, I recommended let's distribute to drop parentheses. So we are going to distribute the 5/9. Notice the parentheses says start here, end here. Okay, so we have 5/9 times 18x. Remember, if you need to, do a little bit of side work. There's nothing wrong with putting some of that computation on the side so that it doesn't clutter your workspace. So we have 5/9 times 18x. 18x being a whole number, you can actually write that over a 1. When we multiply fractions, we always look to reduce first. We want to make life as easy as possible. It's hard enough, right? So we can say here, the 9 and the 18 definitely reduce. We can divide both by 9. 9 goes into itself once and into 18 twice. And now we notice we have 5 over 1 times 2 over 1x, and that's going to leave us with 10x, which is actually really cool. So at first we're probably saying, okay, we have fractions, we're like getting ourselves mentally ready to deal with fractions, but then after we multiply, we notice, oh, it's actually an integer. That's pretty cool. Let's do that again. 5/9 times -9. Notice right away, these 9s are going to cancel. 9 goes into 9 once, 9 goes into 9 once. That leaves us with -5. We distributed. We no longer have fractions because, lucky us, they ended up reducing. Notice here on the right-hand side, we see a 12 plus 13. I would advise you, anytime you can combine like terms, you just should. You just should, right? It's a good habit to get into. 10x minus 5 plus 10x equals 25. At this point, it becomes let's just solve this. Hi, Kevin. So let's combine like terms. We have 10x plus 10x is 20x. We have a minus 5 still is equal to 25. Notice we want to isolate our 20x, so we are going to bring the -5 over to the 25 by using the opposite operation. Opposite operation to move to the opposite side of the equals. Notice that -5 and +5, they cancel, leaving us with a 0, but I'm not going to write 0. I'm just going to note 20x plus 0 is simply 20x. And 25 plus 5 is 30. At this point, we're going to divide by 20. And every time we have an answer that is a fraction, we must always say, okay, is it possible to reduce this? Notice they both end in a 0. And from our discussion in Unit 1, we said that, oh, wait a second, any number that ends in a 0 is divisible by 5, but it's also divisible by 10. We want to divide by the bigger number. So if you divide by 10, that's essentially the same thing as canceling out those zeros. Cool, right? So you're left with 3 over 2 as your final answer. Awesome. Yes, perfect, Kayla. At this point, I want to take a look at number 8 again together because I know we've been away from each other since Thursday, and I want to make sure I'm breaking off any tiny bit of rust, although there shouldn't be any rust because you're all working on your Lumen homework, right? You're doing all your homework over the weekend, right? Right? Okay. All right, so let's take a look at number 8. We have negative 15 over 4g plus 21 over 5 is equal to negative 11. I personally feel that that's really cramped. It's just so cramped in that space. I'm going to rewrite it just to give myself some room. So negative 15 fourths g plus 21 fifths is equal to negative 11. I just spread out each of the terms. It makes it easier. I can see everything. It makes me happy. So notice here that I have 1, 2, 3 terms. I have more than one fraction right away. I notice, okay, not a big deal. But I don't want to deal with fractions, so I want to cancel them by multiplying by the LCD. Notice here I included the strategy just so you could see these in your notes every single time. Distribute to drop parentheses if you need it. We obviously don't for number 8. But then multiply every term by the LCD to cancel fractions. Yeah, why not? Let's just do it. So our denominators are 4 and 5. Notice this negative 11 is over a 1. If you would like, you can write that in there. Our integer, negative 11, is over a 1. That's pretty cool. So let's multiply every term by the LCD. When I multiply every term, notice that I put each term in parentheses first. My personal style, I like it. It helps me to see things a little bit better. And then I'm going to make a note of what that LCD is. So in this case, we're going to recognize that our LCD is 20. Okay? So we have 3 terms. We packaged each term in parentheses, and we're going to multiply each term by 20. As a reminder, you're multiplying by a 20, not a 1 over 20, right? That means the 20 is in our numerator. So when we go ahead to simplify, you should see this as 20 is in the numerator, so is the negative 15, the 4 is in the denominator. If it's helpful, you could even place the 20 over a 1 so that you could say, oh, I can reduce here numerator for denominator. Right? That's how we reduce. We divide something out of the numerator and the denominator. So 4 can divide into 4 once, and 4 goes into 20 5 times. So far, so good. I'm going to then notice here that this says 5 times a negative 15. So 5 times a negative 15g is going to give me negative 75g. The cool thing here is to note that they're both over a 1. So negative 75 over 1 is just a negative 75. So negative 75g. We're very careful to keep track of every single piece that we see. That's how we have to do the math. We have to be super careful. For our second term, 5 goes into 5 once and 5 goes into 24 times. That leaves us with 4 times 21. And that's going to give us 84. Lastly, we have a negative 11 times 20, and we don't need our calculators for this. We already learned how to multiply 2-digit numbers by 11. So you separate the 2 and the 0. 2 plus 0 is 2, and because a negative times a positive is a negative, we get negative 220. That quick shortcut makes life a little easier, and we have fun along the way. At this point, we notice, hey, I don't have a single fraction anymore. I can just simply go through the motions of solving this problem without any hesitation. Notice 84 and negative 220. These are like terms, so you'll want to bring the 84 over to the side away from the term we're solving. Remember, because we're solving for g, we want this term to be alone. So we want to subtract the 84, use the opposite operation to move to the opposite side of the equals. And then notice here my terms will cancel because they're additive inverses, otherwise known as opposites. So we bring down the negative 75g. We don't need to write plus 0. We bring down the equals, and then these are the same sign. Remember this phrase, same sign sum, right? You're going to add these two values, and you're going to keep the sign. Think of it also in terms of money. You're in the hole, $220. Ouch. Then you owe another 84. Ouch. So you're going to say, okay, if I owe 220 bucks and I also owe another 84, I now owe 304. Does that make sense? Think of it in terms of money. I find it always kind of relates it back to what we're so used to. Last up, we're going to get G completely by itself. We have negative 75 times G. The opposite of times is divide. So we divide by the coefficient of G. The coefficient of G is the numeric part of that term. So negative 75 is its coefficient. These divide out, gone. The next thing to note is that a negative divided by a negative is a positive. So that's our first way to simplify our fraction. Always check your signs. If you have a negative divided by a negative, please cancel that out. So then we have 304 over 75, and notice Kayla mentioned that fraction cannot be reduced, and she's absolutely right. So in this case, we'll simply say that our answer is positive 304 over 75. And that concludes problem number 8. I'm hopeful that as you are working through this problem alongside me, that you're saying, okay, that's cool. That's actually pretty straightforward. It's manageable. I like the idea of eliminating fractions to move through the problem. I'm hoping you adopt this style because it'll save so much time, and it's something that you can use in future math classes as well. Remember, we're building a foundation here. We're building a foundation from which all other math classes will be layered on top of. Okay, think of it that way. This math is never going to change, which is super cool, and that's why I love it. Okay. Your turn. I would like you to do number 9. So I'm going to read this out loud first. We have negative 21 over 4 times 3b plus 7 minus 9 over 2 is equal to negative 8 over 3. I'm going to give you about 2 or 3 minutes to give this a shot. And what I'd like you to do is when you have your answers, please share it in the chat. All right, 2 or 3 minutes starting now. Okay, so we have several answers in the live chat, so I'm very excited to unveil what the answer is and the procedure for working through this problem. And that's totally okay, Kayla, no big deal. Let's take a look together, okay? So notice here, we are going to distribute first to drop parentheses. So we have negative 21 over 4 times 3b. I'm going to write less on the side because I want you to get into the habit of thinking about this more mentally as well. If you want to write your side work, go for it. Please feel free to do so. So we have negative 21 over 4 times 3b. Well, we know that 21 times 3 is 63, and we know that we can't reduce, so it's going to be negative 63 over 4b. That's our first term. Next, we have negative 21 over 4 times 7. Notice the 4 and the 7, there's nothing that's reducible there. So we have minus, and then 21 times 7 is 147 over 4, right? 21 over 4 times 7 over 1 is 147 over 4. Next, we have minus 9 halves is equal to negative 8 thirds. One of the biggest concerns I see here is your signs. Be super careful that you keep track of all of those signs. We have a lot of negative numbers, which is totally okay. We just got to keep track of those. Next, I see a whole bunch of fractions, and I want to simplify this so that my life is easier. So I'm going to cancel fractions by multiplying by the LCD. I have a 4, a 4, a 2, and a 3. Remember that when we find our LCD, we look for the lowest common multiple. So the multiples of 4 are 4, 8, 12, 16, 20, etc. Multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, right? And then multiples of 3 are 3, 6, 9, 12, 15. So I'm hoping, thank you, Claire, and thank you, Kayla, but I'm hoping that you're going to see that the LCD for all of these denominators is actually going to be 12. Kayla, that's okay. Amanda, perfect. So our LCD is 12. Now, take each term, 1, 2, 3, 4. Package them in parentheses, just like I did here. And we're going to multiply each term by 12. 12, 12, 12, 12. Perfect. Now that we've multiplied each term by 12, we can reduce because we have a fraction times a fraction. And Claire, that's actually okay. Even if you said 24 was the common denominator, guess what? It is a common denominator. It's not the lowest, but it's still going to work because you found a common denominator. So no biggie. Seriously, no biggie there. Perfect. 4 goes into 12 3 times. And now we have 3 times negative 63b, which is going to give me negative 189b. 4 goes into 12 3 times. If you're doing this and you're thinking, sheesh, I got some really big numbers, that's okay. That's okay. We're not doing these, I'm not doing this in my head. I've got my tool just to kind of guide my process. So 3 times 147, that's going to give me negative 441, right? Or minus 441. It's the same thing. Here, 2 goes into 12 6 times. So negative 6 times 9, that's negative 54. And then 3 goes into 12 4 times, and 4 times negative 8 is negative 32. My life's pretty easy. I'm like, okay, this is totally manageable. I love it. We're going to combine like terms first. I see that negative 441 and negative 54 are on the same side, so I'm just going to combine these two together. Remember, the only time you use an opposite operation is if you're bringing the term to the opposite side of the equals. But because these are on the same side, you're going to say, okay, well, I have a negative 441, and I'm going to minus 54, so that leaves me with negative 495. Okay, you're simply combining like terms. Think of it as what we would do if we were applying that idea of PEMDAS. And Rachel, you can leave your work as fractions and move through the problem that way. It just depends on your own personal style. I tend to like to eliminate fractions just so that I can move through the problem a little bit quicker. But that's your call. Totally up to you. Next, I'm going to bring the negative 495. I want to bring it to the negative 32, which means I must use the opposite operation to do so. Opposite operation to move it to the opposite side of the equals. Notice here, your terms will cancel because they're additive inverses or opposites. I'm going to bring down the negative 189b, and now I have negative 32. I'm going to plug in my calculator exactly what I see. Negative 32 plus 495. That's going to give me 463. Notice it's a positive. Think of it in terms of money. You are in the whole $32, but then you make 495. Right? You just got out of that hole. So keep that in mind as you're doing these problems to make sure that you're getting a value that makes sense. Last step, we're going to divide both sides by negative 189. So we cancel here, and we're left with b is equal to positive divided by negative is a negative. So I'm going to bring the negative in front, right? We could put it in the numerator with the 463 or in front of the fraction, totally up to you. But I also notice that 463 over 189 does not reduce. So excellent work, everyone. Excellent work moving through this problem and figuring out that the solution here is a negative 463 over 189. If there was an error somewhere, that's okay. This is a time and place to do that in class when we have an opportunity to learn from one another. As always, if you have any questions about this problem or previous problems, don't hesitate to ask in our live chat. Having said that, Let's continue to the next page. Let's solve linear equations with variables, this time on both sides of the equation. So I want you to consider that the rules don't change. You don't have to worry about that. Now you just have an extra step. You have variables on both sides of the equals, and you just have to say, where do I want to bring it, right? Do I want to bring the term to the left side of the equals? Remember, you got to use the opposite operation. Or do I want to bring that term to the right side of the equation? I know you're facing me and it's backwards, whatever. So that totally is up to you. That style of which place you move it is totally up to you. In terms of actually solving the equation, think of it like a dance. You're probably thinking in your mind, what is she saying right now? And the process of kind of moving terms, chances are if you move a term from the left to the right, you're going to have to move a term from the right to the left, etc. It's going to feel kind of like a dance. And I'll show you that as we work through some of these problems. The first thing is, let's talk about the three types of linear equations. So notice in your notes, your goal is to isolate the indicated variable. If you're solving for a specific variable, that term with the variable or those terms with the variable need to be on the same side away from all of the other terms, meaning if there are any constants, get them away. If there are any terms with different variables, get them away, 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 okay? Isolate that particular term, and then you simply go through the motions to solve, okay? I would advise you to clean up your equation first, distribute to drop parentheses, combine like terms, then you start using the opposite operation to move to the opposite side, okay? It's like you're fixing things up, making it nice and neat, and then you start doing the dance, okay? You clear up your space and then you dance. Weird, but it works. That's how my brain works. What can I say? My second piece of advice to you all, and you'll see it in the notes, is please move the terms with the variables first, not the constants. Move the terms with the variables first, and you will see very quickly why we move the terms with the variables first before we ever touch any of the constant terms, okay? So the terms with a letter, those get moved first. Let's take a look at the three types, and then we'll see some examples. The three types of linear equations, you have a conditional linear equation. Every problem we've done so far, every linear equation that we've solved so far, was actually a conditional linear equation. And all that means is that it has one solution, right? So for example, when we solved our previous problem, negative 463 over 189, that is a conditional linear equation. We had one solution, and that was the solution. But we also have two other types of linear equations. We have one called an identity. When you have an identity, essentially the way you can identify this is you will notice both sides of the equation, sorry, I abbreviated here. You will notice both sides of the equation are identical. Okay, that's super, super important. Both sides of the equation are identical. If at any point you notice that both sides of the equation are identical and you're responsible for solving, you can simply say there is an infinite number of solutions. Okay, that's what you'd end up writing. Infinite number of solutions. Think of it as if I had x plus 3 equals x plus 3. Yeah. Yep. But then what if I said, okay, so then what's x? You're going to say, well, it could be 1, because 1 plus 3 is equal to 1 plus 3. And then someone else could say, oh, it could be a negative 5. Negative 5 plus 3 is a negative 5 plus 3. And then someone else will say, wait a second, any number we put in there is going to work because they are totally equal, balances out. They're the exact same value on either side. Okay, infinite number of solutions. That's an identity. Every time I snap, my dog Twiggy is thinking I'm like getting her attention, and I feel kind of bad. Okay, I'm going to try to refrain from snapping. All right, contradiction. A contradiction is different. Think of contradiction as being like no, like a no statement. It's a little bit harder to see, but I will note here first that a contradiction has no solution. Okay, it's harder to see until you kind of get used to that. So the idea with a contradiction is that the terms with a variable are on opposite sides are identical, but the constants are different. So I'll give you a quick example of what I mean by that. So an example of a contradiction is something like 4x minus 11 is equal to 4x plus 3. Right? That's an example of a contradiction. You're probably thinking to yourself, well, okay, I kind of see it, not really. Well, let's play around with this. If you were to say x is equal to 1, 4 times 1 minus 11 is equal to 4 times 1 plus 3. If you made that claim, I would look at you funny. Because I would say, how is it possible that 4 times a number minus 11 is the same as 4 times a number plus 3? Because these are both x, they have to be the same value. So 4 times the same number minus 11 can't possibly be equal to the same expression plus 3. So right away, you can notice that nope, no solution. And that's what you would say. When I show you these examples, I'll take this a step further in case you're kind of looking at this and you don't notice right away that this is a scenario. And that's totally okay. It's not a big deal. I want to show you how we reveal that. And then we could say, oh yeah, that's definitely no solution. So let's take a look at number 1. We have 6x over 3 plus 5 equals 4x minus 2x plus 15 over 3. I really hope that you're looking at this critically first. Don't dive in terms of, oh, let's combine these terms. We can, but I want you to be critical of the fractions. 6x over 3, oh, 6 divided by 3, that's 2. So let's just simplify it. 6x over 3 is 2x plus 5. Sure, we can combine these two. 4x take away 2x, that's just 2x. And then 15 plus 3, wow, I said plus. 15 divided by 3 is 5. Notice what you have here. 2x plus 5 equals 2x plus 5. Recognize that both sides of the equation are identical. They're exactly the same. So we're going to note here, this is an identity. So it's almost like saying, oh, I know exactly what this is. So because it's an identity, what that means is, think of identity as like a positive, right? Oh, wow, all solutions are possible. So we're going to say that this has an infinite number of solutions. That's what you would write as your answer, infinite number of solutions. Okay? Infinite number of solutions because it's an identity. I'm going to rewrite that and I'm going to take it a step further. What if we didn't see that right off the bat? Right? Oh, and Patrick actually typed in something very important into the live chat. He typed in 2 little zeros. That's supposed to represent infinity. In your Lumen, you can do the same thing, but check to make sure it's asking for you to write it in that format. The 2 zeros side by side, or the 2 O's, will represent infinity. So we can think about it like that. If you struggle with writing infinity, turn the paper to the side and draw an 8. That'll always work. So now, what if we didn't recognize that this is an identity? Okay, no big deal. Our first step, according to my advice, is we need to move the term of the variable first. Kevin, an octopus. That's pretty cool. I have to take a look at that because I did not see that. So we're going to subtract 2x from both sides. Notice 2x minus 2x leaves us with a 0. 0 plus 5 is 5. Bring down the equals. 2x minus 2x is 0. 0 plus 5 is 5. 5 equals 5? Yes. So because this is a yes statement, we could say, oh, that means it's an identity. They're identical. Infinite number of solutions. Okay? Identity, infinite number of solutions. Let's take a look at number 2. 60 seconds. I would like you to solve this and tell me what your answer is. 60 seconds starting now. Okay, so let's distribute. Negative 3 times 2y is a negative 6y. Negative 3 times a negative 5 is positive 15. 2 times a negative 3y is a negative 6y. 2 times a positive 7 is positive 14. Right away, notice that negative 6y and negative 6y, they're the same. So we're saying negative 6y plus 15 is the same as a negative 6y plus 14. Craziness. Yes, Kevin, be super careful with your sign. It should be negative 6y plus 15 because a negative 3 times a negative 5 is a positive 15. Another quick piece of advice, read it out loud. Read it out loud, say the operations, say what it is that you're combining with whatever operations, just so you can hear it. And if you can hear it in your mind or anything like that, it's easier to transfer to the paper. And Kevin, that's okay, right? We learn strategies for ourselves as we move through these problems. And sometimes you're right. Sometimes it means just slow it down just a touch. Okay, we can say at this point, no solution. So I'm going to go ahead and write that. In Lumen, you may be asked to write does not exist, DNE, that'll work as well. Or maybe you have the option to select no solution. Either one was totally fine. Let's say, and again, I'm rewriting this, and let me make a note, this is a contradiction. This is definitely a contradiction. I'm rewriting the problem because I want to show you what happens if we don't recognize it off the bat. Always move your variable terms first, not the constants. These are constants. No, no, no. Let's start with the variables. So we have a negative 6y. Let's add 6y to both sides. What you do to one side, do to the other side, right? We're moving the term. These are opposites, so it cancels out, leaving you with a 0, but 0 plus 15 is still 15. Negative 6y plus 6y, these are opposites, so they leave you with a 0. 0 plus 14 is still 14. But is 15 equal to 14? Absolutely not. That's literally like me saying, I know I owe you 15 bucks, but I'm only going to give you 14 because they're the same. You would look at me like you're crazy and I'm never lending you any money ever again, right? So just think about it logically. It doesn't make sense. It's not true. No solution. So I'm going to put here, I'm going to cross that out so it's not equal to, 15 is not equal to 14, which means I can say no solution. Think of that as a no statement. Okay? Hopefully that's clear. So we've seen conditionals, we see an identity, we see a contradiction. That's essentially what it looks like. So we have to be prepared for any one of those three types of linear equations. Let's turn the page. Number 3, we have 7p plus 5 is equal to 2 times p minus 3 plus 11. And then for number 4, we have 8/5 a plus 12/5 is equal to 4/3 a plus 2/3. I would like you to have fun with both of these problems and let's see what you get. Go for it. Okay, we have a lot of answers coming in for number 3. And I think what I'd like to do is walk you through this particular problem. So first off, we're going to distribute 2 into the set of parentheses, right? So we have 2 times p and 2 times negative 3. This leaves us with 7p plus 5 is equal to 2p minus 6 plus 11. The next thing I'm going to do is I'm going to combine like terms. So we've got 7p plus 5 is equal to 2p, and then a negative 6 plus 11 is a positive 5. Now, if we think back to what we did on our previous page, when we tried, our hand at solving, even though we had an identity or a contradiction, is we always move the variable terms first. So here's what I would like you all to do. At this point, I would like you to bring the 2p over to the 7p. Because we have a positive 2p, right? We want to use the opposite operation to move to the opposite side. We're not separating the 2 from the p. We want to move the entire term. I'm going to make a quick note here. Use addition or subtraction to move terms. Okay? Use addition or subtraction to move terms. So we are going to subtract the 2p from the right and bring it over to the left. That's my personal preference. You could have moved the 7p over. The only issue is if we moved the 7p over, we would have had a negative value. And it's not a problem. You can. I just prefer to try to keep our values positive as much as I can. So we have 7p take away 2p is 5p. Bring down the plus 5, right, equals, now 2p minus 2p, that's 0. They cancel each other out. So 0 plus 5 is 5. I'm going to move this over here. So we have 5p plus 5 is equal to 5. We are not done. We cannot stop moving through this problem. At this point, these are my like terms. I'm going to bring 5 over by subtracting it. Use the opposite operation to move to the opposite side. So notice how we're subtracting the 5. These cancel each other out. So we have 5p, and then these cancel, leaving you with 0. 5p plus 0 is 5p. But 5 minus 5 is not undefined. 5 minus 5 is not no solution. Guys, 5 minus 5 is 0. At this point, we have 5 times p is equal to 0. Well, I still need to solve for p. So I'm going to divide both sides by 5, and 0 divided by 5 is 0. It's not undefined. 0 divided by 5 is 0. So for number 3, even though this looked a little crazy and you're thinking, well, it's a 0, can that be a solution? Yes. You can have $0 in your bank account, right? It would be terrible, but it's totally possible. So you can certainly have a value equal to 0. Hopefully that made sense going through that process. It is a conditional statement because there is a solution. Not an identity, not a contradiction after all. So we have to be super, super careful as we move through the problems. Again, recap. When you're looking at your equation, distribute to drop parentheses, first thing. Yes, Kayla, nice job. Then you combine like terms, clean it up, and then you move your terms from one side to the other. Notice that we moved, I'm actually going to show you this real quick. Notice we moved the 2p from the right to the left, and then we moved the 5 from the left to the right. So that's the dance that I was talking about, okay? That's the dance. It's like da-da, 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 all right? So I know it sounds silly, but think about it like that. It might help, all right? We don't have enough time to do number 4. We'll do that tomorrow, first thing, all right? And I snapped again. Luckily, she's not in the room, so it worked out. All right, everyone, have a wonderful rest of your day, and I'll see you all tomorrow. Bye.